everyone to Ask the Experts. I'm Tim Messagy, and today we're going to be talking about the chipsets for client memory modules. And in order to do that, I am joined by my expert, Carlos Weissenberg. And Carlos is from our memory interface chip business here at Rambus. Welcome, Carlos.
Hello, everyone. I'm happy to be here.
Great, Carlos, great to have you here. Why don't we kick off with this question? Can you talk about some of the big trends that are shaping the PC market?
Okay. The PC is the premier platform for productivity, content creation, and gaming. In the industry, we also refer to this as the client market.
Right.
The client market is composed of the desktop PC and the notebook PCs. There is still a large percentage of users and businesses that prefer the desktop as it offers flexibility, upgradability, and lower costs. For
Mhm.
example, there are many businesses that buy desktop PCs since their employees do all of their work at their desk.
Right.
However, for the last 10 years, we have seen the market steadily move towards the notebook. Users want the ability to take their PCs with them wherever they go, but they don't want to sacrifice any computing horsepower. They are looking for a PC that is thin and light with excellent battery life.
And as we move to more AI-driven applications, the demands for that horsepower only increase. Can you talk about what the implications are, given the growth of AI, what the implications are on the client computing architecture?
I'm glad that you brought this up. We're seeing AI drive a real renaissance in the PC. I think we'd all love to have our own personal assistant on our screen. PCs ramping in 2025 will be marketed as AI PCs. They will have dedicated hardware optimized for AI inferencing. AI inferencing requires high memory capacity and bandwidth to be able to give real-time results from a large model that's contained on your PC. The rapid development of AI models and new applications and the use cases that they enable will continue to drive client memory requirements. AI is pushing the industry to offer advanced memory interface chipsets and new module form factors, which can support higher data rates and higher density DRAM chips.
Carlos, you mentioned new memory module form factors. One of those is LPCAMM2. Can you explain what LPCAMM2 is and what its benefits are?
I would love to. LPCAMM2 is a memory module that enables the use of LPDDR memory in the notebook form factor.
Okay.
The first version of LPCAMM is currently proprietary, while LPCAMM2 is a standard module defined by JEDEC. LPDDR memory offers higher data rates and consumes less power than standard DDR5 memory. LPDDR was originally developed for mobile phones. It was designed to be soldered down close to the processor in order to provide improved performance and maintain signal integrity. As a result, historically, when LPDDR is used in PC notebooks, the memory configuration is fixed at the time of motherboard manufacture. So they put it down, the capacity, how much memory is used, speed, it's all fixed. There's no
You get what you
flexibility.
get.
Yes.
Exactly.
LPCAMM2 overcomes the limitations of soldered down LPDDR memory while providing the same benefits that LPDDR's power that is provided by LPDDR, such as power and performance benefits.
Okay. Yeah, I'm sorry. Go ahead.
LPCAMM2 offers the flexibility of a module with a compact, low height form factor that supports the ultra-thin notebooks. LPCAMM2 also provides the needed signal integrity, and it allows for memory expansion or memory repairs that were not possible with the LPDDR that's mounted directly to the motherboard.
Okay. Now, I'm so excited about this next question, but here it is now. Um, and your team just announced chipsets for LPCAM2, as well as some DDR5 client memory modules. Can you describe those?
Traditionally, the desktop PC used UDIMMs and a notebook PC used SODIMMs. Starting at 6,400 megatransfers per second, the desktop PC will use CUDIMMs and the notebook PCs will start using CSODIMMs. The difference is that the CUDIMMs and the CSODIMMs will have a client clock driver, which we refer to as the CKD, to improve signal integrity and to enable higher memory bandwidth and allow us to go beyond 6,400 megatransfers per second and beyond. As part of the memory interface chipset, we also have a power management IC, the PMIC 5120, and this is specifically designed for the CUDIMMs and the CSODIMMs. And then we will also have the Serial Presence Detect Hub, or the SPD hub, for these client modules that I was referring to. Then finally, for the LPCAM2, we have a different power management IC, the PMIC 5200, which is designed to support LPDDR memory on the LPCAM2. And then as part of the memory interface chipset, the LPCAM2 will also have the SPD hub.
Great. Carlos, why should system and module makers look to Rambus for these solutions?
Good question, Tim. Rambus has been an innovator in the memory space in developing memory subsystems for over 30 years. We've had a lot of ingredient innovations along the way that have gone into these subsystems. And these have been necessary to support both servers and feeding multi-core CPUs, as well as for client CPUs that are now bringing in more of this acceleration feature and the AI and just lots of computation. In addition to that, Rambus, more recently over the last 10 years, has really become a first-class semiconductor product company where we have lots of high volume experience in-house. We have strong partners both in the supply chain and the memory industry and the end customer. We really have a strong track record here.
Great. Carlos, thank you so much for sharing your insights. And to our audience, thank you for joining us. We'll see you again real soon here on Ask the Experts.
Thank you, everybody.